So in the last video of the day, we will look at a quick summary and we'll recap the examples, look at one final example that this year I won't be able to cover, which is testing for Gaussians. Okay. So let's do a quick summary of what we've seen so far. Okay. So here are like the main concepts that we've seen, and we are thinking of important definitions when it comes to hypothesis testing. Okay. So one is this notion of a test statistic, which is what is the thing that you actually measure about your experiment. Okay, and then there is this notion of a success condition, and there is this whole notion of a significance level, which is which we defined as the probability that test succeeds given the null. Okay, and like we saw in the example with the coins, you may not actually exactly compute this. We are only interested in getting a bound for this, right? So usually interested in saying that this is less than or equal to 0.05 or some quantity like that, some pre-chosen threshold. Okay, and the mechanism of the test is as follows. Okay, so you have a claim that you would like to test. Okay, and that's like that's where we start off, and then using that claim you formulate the null hypothesis and the alternate hypothesis. Okay, and this depends on the setting, like we saw, like even in like the couple of settings we saw, the way we came up with this was slightly non-trivial. Okay, and so you formulate a null and you formulate an alternate hypothesis. Okay? And then you've got to decide on what experiment you will conduct and what observations you will draw from this experiment. Okay? So that's what you decide on. Okay? So in the first example we said that okay, I'm going to put 4 cups of tea of method A, 4 cups with method B, and I'm going to present them to the lady, right? And in the second case we said I'm going to toss 20 coins. Okay. So choice of these numbers, the way in which they are presented, and so on, these are all part of the this is why this area is called the design of experiments. So this is all part of the experiment, and the observations are basically what readings you get from these experiments. Okay. So that's what you decide on, and you also decide before you actually observe any data on what the test statistic is going to be and what the actual test is going to be. Okay, so like in the coin toss example, the test statistics was the number of heads that came up. In the other example, it was the number of times the lady was right. Okay, and the test itself is the threshold that we were using, right? So that's the test itself. Okay, and again, I stress this as a point, which is that both these things must be decided before we actually run the experiment. Okay, and then the other thing that we can now do is you can compute the significance level of this test, right? So which is the probability that the test succeeds given the null hypothesis. Okay, and so deciding on these things allows you to compute this probability, right? So like we did in the coin toss example. Okay? And often you, based on the significance level that you desire, you may actually go back and decide the test itself, right? So if you remember earlier we said that, I mean, in order to actually pick C, we used the calculation that we did over here. Okay, so these are like the basic steps, okay, that you do in any hypothesis testing problem. Okay, so just to recap, so in our first example, the experiment was 4 cups of type A, 4 cups type B, and present them to the lady, and the test was check if the number of correct things, if she got all of them correct. Okay, even if we went a little bit lower, we saw that the probability of getting that answer under the null hypothesis was still high enough. Okay. And if this test succeeds, if the number of correct is more than or equal to 8, okay, then you reject the null hypothesis. Okay, in this context, it meant that you conclude that okay, I am now fairly certain that the lady is not randomly guessing. Okay, so that is the meaning of rejecting the null in this case. Okay. And the significance level of this test, which is the probability that the null actually got through somehow, was equal to 1 by 70. This means it was less than or equal to 1 by 70. Okay, so that is the significance level. In the second test, the hypothesis we wanted to test was if a coin was highly biased, like if it had a bias of 0.8 or something, and we said the null hypothesis was p was less than or equal to 3/4. That was our null hypothesis. And the test that we came up with is you toss it 20 times, and so that's the experiment. Toss it 20 times, and you accept if the number of heads is more than or equal to 19. Okay, so if if all or all but one of those of the tosses were heads, so that's when you reject the null hypothesis. Otherwise, you say that basically there is insufficient evidence to reject the null hypothesis. Okay. And the significance level of this test, like we saw, was 0.25, 0.025, which is like 2.5%. Okay, so let's now consider this other very common setting of hypothesis testing, which is testing the mean of a Gaussian distribution. Okay, so a motivational story for this is the following. So let's say you have a baker who claims that his bread weights have a Gaussian distribution, and let's say he claims that the mean of this distribution is 1000 grams and the variance is 1. Okay. So you might have some reason to suspect that okay, that baker is not correct, and the mean is actually something less than 1000 grams, let's say. How do you now test this hypothesis? Right, test your hypothesis. Okay, so you have to start. So this is a much more continuous example than the kind of examples we've been looking at before, right? So earlier we had some value p which we wanted to test if it was below a certain value, or we had examples where we wanted to know if a lady was just guessing or not. Here it's like a much more continuous problem. The values themselves are not 0, 1 or anything, they are actually some real valued numbers. Okay, so how do you model this problem? Okay, so but it turns out hypothesis testing works exactly the same way even for this case. Okay, so you start off with a null hypothesis. Okay, so when the null hypothesis is, maybe you're wrong and maybe the baker is right, right? So mu is actually equal to 1000 grams. Okay, and the alternate is, let's keep the alternate simple and say that mu is less than 1000 grams. Okay, you could even say things like mu is not equal to 1000 grams, or you could say stuff like mu is less than 950, maybe that's your suspicion, but it doesn't matter. Okay, so let's keep it simple, keep the alternate as mu is less than 1000 grams. So now what is a reasonable test for this, right? So a reasonable test for this, at least intuitive test, is, take a whole bunch of samples. Okay, take buy like 50 loaves of bread, 50 samples. Let's call them x1, x2 up to x50. Okay, so these are your observed weights for these 50 samples. Okay, and check how many are less than, suppose I do something naive and check how many are less than or equal to 1000 grams. Okay, this number is going to be pretty high even when mu is equal to 1000 grams. right? Because if this value is distributed as a Gaussian around 1000 grams, okay, right, so this is 1000 grams, mu equals 1000, and variance is 1. Okay, so this number is actually 1001, this number is 999. Okay, so variance 1 is probably a very strong assumption in this case, but you know, it doesn't matter. Okay, so this is the kind of picture you have, right? So if mu is 1000 is this quantity, and right, so if you test how many are less than 1000, then you know 50% are going to be roughly less than 1000 even in this case. Okay, so you have to have a little bit of a slack in your test. Okay, so you may want to test so the test can be count the number of loaves whose weight is less than, let's say, 995 grams, okay, and check if this number, which is the number of loaves, okay, is more than, let's say, 5. Okay, so your test is basically you are testing if more than 5 of the loaves have weight that is less than 995 grams. Okay, if so, you will reject the null hypothesis. Okay, so you will say that you know, there's no way this could have happened if mu was actually equal to 1000 grams. Okay, so let me give you a brief sense of why such a statement is true. Right. So this follows from this nice property of a Gaussian, that the tail of a Gaussian decays extremely strongly. Okay, so if I look at 995 and I ask you what is the probability that if mu were equal to 1000, what is the probability that a given loaf has weight less than or equal to 995? Okay, this turns out to be only something like e to the minus 25 by 2, which is really small. Okay, so it's just like 1 by a million or much smaller than that. Okay, so maybe something around this order. Okay, so there is for a given loaf, it is extremely unlikely that its weight is actually less than 995 if mu were actually equal to 1000. Okay, and the variance was 1. And now what we are saying is that among 50 samples, what is the probability that you will observe 5 of these super unlikely events, right? So that's extremely small. So in fact, the significance of this test will be very, very small. This test will be really tiny. Okay? Will be like 1 by 10 to the 20 or something. Okay, so you will, if the null hypothesis were actually true, you will actually, with extremely high probability, you will reject the null hypothesis with this test. Okay, so you can, my point is not for you to really understand this example. The point is that this framework of hypothesis testing can be applied to a whole bunch of contexts, including the case when you want to test the mean of a Gaussian, the variance of a Gaussian, things like this. And yeah, so there's also this nice connection between hypothesis testing and confidence intervals, and I think this example should serve to illustrate that. Okay, so we are not going to have time to go into this, but this is like a teaser. If you guys are interested, you should read the corresponding chapter in the textbook. Okay, so that's basically what I wanted to say about hypothesis testing. Okay, and the important thing is this is the summary, right, which is that you have like these are like the key notions, and you have this like few steps that you need to follow, which is basically formulate the null, formulate the alternate, okay, and you decide on the experiments and the actual test, and using that you compute the significance level. Okay, and there are various forms of tests, like I said. There is this Neyman Pearson test and things like that that are more sophisticated. But on the whole, This is the goal of hypothesis testing, that you have you have this null hypothesis which is saying that nothing very interesting is going on, and you would like to build evidence that rejects this null hypothesis. Okay, and if you found enough evidence, then you know that something interesting is going on. Okay, that's a rough idea. Okay, so let's stop here for this lecture.